It's a marble, or this we would drop marbles and create a marble pixel art machine. Marbles, yes. Do you have the marbles on hand?
Here we have our marble pixel art machine, and to the left we have the controller, controlled by two joysticks and an arcade button. Then we have our two actuators, the two stepper motors. Then we have our servo motor controlling the water wheel in the middle. This is our 16 by 16 canvas where the marbles would drop into. And this whole machine is powered by the Raspberry Pi Pico and our 12-volt power supply, as seen right there. In the front of the dropper box, we have our IR obstacle avoidance sensor, which detects whether a marble has fallen through the chute. After a few seconds dropping each marble in a specific spot, we have our finished product. And we have an A. Please give us an A. Please.
And I'm gonna talk about the logic of the code. Here in this diagram, it shows the logic of the entire code. The black lines are representative of states that go into another state. So for example, when the button state is equal to 0, otherwise it's pressed, the servo will rotate 180 degrees and back. For non-black lines that aren't arrowed or colored, that means represented that two states have to be true for the next state to occur. So for example, the x-axis joystick has to be moved left, and the universal stepper motor function, which I'll explain later, has to occur so that the x-axis motor can rotate kind of clockwise. Yeah. So for the logic of the code, it can mostly be broken down into the IR sensor, the servo and button, and then also the stepper motors. I'll explain the stepper motor first. The stepper motors connect to the x-axis and y-axis joystick, which can be in basically three states where they're either sleeping or they're moving in whatever direction that they're supposed to be in, so up, down, left, right. From there, the universal stepper motor function takes in whatever direction that the joysticks are in, and these essentially connect to the dir pin of the motor drivers, which drives the motor. So if the joystick is moved to the right, the x-axis motor will rotate counterclockwise, vice versa. For the button and servo, the buttons are either in a high or low state, so they're in a high state whenever they're not pressed, and then they're in a low state when they're pressed, at which point it will tell the servo to rotate 180 degrees and back, and this essentially drops the marble. And the final part is the IR sensor. The IR sensor is the most complex one, I would say, where initially when the code starts, it takes in a marble state, and this starts at none. This is very temporary though, because it will go to either a detected state or a ready state, and this is based on whether the IR sensor actually detects a marble. So the IR sensor state is 0, it detects a marble. If the IR sensor is at 1, it means there's no detection of a marble. And so whenever the marble state isn't detected, but the IR sensor detects something, the code will state that a marble is detected, it's in the detected state. And whenever the IR sensor doesn't sense anything and the marble state isn't ready, then it will say that the marble state is ready and it's ready to drop. there's no function for the marble stick to go into none after it goes from none to detected and none to ready. So essentially that the code will just continually loop between detected and ready based on whether you're dropping a marble or not. And yeah, that's how the code works.